Hello everyone, now we'll see exercise 5.1, that is problems based on the continuity. And if you think that you can solve those problems, then no need to watch this video. You can solve by yourselves because these problems are simple. Refer textbook and take down the question and solve it. Okay? Or else listen here. Prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. We will see at x is equal to minus 3. You have to solve x is equal to 0 and x is equal to 5. We will check it at the point of x is equal to minus 3, right? X is equal to minus, anyway one function is given, right? There are no two functions defined. So this is now limit of, you have to check the left hand limit as well as the right hand limit. After that you have checked that point. So now I will consider f of x, limit x tends to minus 3 left hand side, that is f of x. Since only one function is defined, so this will be now limit of x is tending to 3 minus 3 from the left hand side. The function will be 5x minus 3. So this is, we have to substitute x as minus 3. So 5 into minus 3 will be minus 15, right? Minus 15 minus 3 will be equal to minus 18. So this is the left hand limit equal to minus 18. Right hand limit of x is tending to minus 3 plus f of x. So the function is same. Limit of x is tending to minus 3. The function is 5x minus 3. If you substitute x is equal to minus 3. So this is also equal to minus 18. So left hand limit is equal to the right hand limit. Now we will check at the point f of minus 3. So f of minus 3 is now 5 into minus 3 and minus 3. So this is 5 into minus 3 will be minus 15. Minus 3 is equal to minus 18, right? So here we can see this left hand limit is equal to the right hand limit, that is equal to the value. Finally what you have to do is just you have to write limit of x is tending to the point minus 3, f of x is equal to f of minus 3. So by this we can say that the function is continuous at the point x is equal to minus 3. Similarly solve x is equal to 0 and x is equal to 5. Now you have to check the continuity of these problems. Okay, first problem is given f of x is equal to x square minus 25 divided by x plus 5 and the value of x is not equal to minus 5. Here x square minus 25 can be written as, right, x plus 5 into x minus 5 divided by x plus 5. You can simplify this, right? So the x plus 5 and x plus 5 will get cancelled. So this is equal to x minus 5. So since the function f of x is being a polynomial function, directly you can say that this function is continuous. Why? Since the x minus 5 is a polynomial function, right? F of x is continuous at every point of C. Continuous at every point of C. This is the first. F of x is equal to modulus of x minus 5. You know that modulus function is continuous, but here you have to prove this one. First we will define this function. F of x is equal to modulus of x minus 5. So this will be equal to x minus 5 when if the value of x is greater than or equal to 5. Is it clear? You know this one. If it is mod x is defined as, what we define, mod x is equal to set containing the x if the value of x is greater than or equal to 0 and this will be minus x if the value of x is less than 0. Here the function is x, in the place of x here we have x minus 5, right? So this is now x minus 5 if the value of x is greater than or equal to 5 and this is minus of x minus 5 minus x, here in the place of x we have x minus 5, minus of x minus 5 if the value of x is less than 5. Is it clear? Now we will check the point continuity of a function at the point x is equal to 5, x is equal to 5 will check. So this is now limit of x tends to 5 minus from the left hand side, f of x is equal to limit of x tends to 5 minus from the left hand side, I mean the value of x is less than 5. So it is minus of x minus 5, minus of x minus 5. If I substitute the value of x as 5, so it will be 5 minus 5 will be 0, minus 0 is equal to 0. So we will check the right hand side limit, that is limit of x is tending to 5 plus f of x. So this is equal to limit of x is tending to 5 plus the value of x is tending to 5 plus means x is greater than 5. Greater than 5 means it is x minus 5. Right? So this will be now x minus 5. Now if I substitute the value of x as 5, 5 minus 5 will be equal to 0. Here the left hand limit is equal to right hand limit. We'll check f of 5. Is it clear? F of 5 will be equal to 5, right? So this is x minus 5. So this is equal to x minus 5. So 5 is now x, the value is 5. This 5 minus 5 will be equal to 0. So by this we can say that left hand limit is equal to the right hand limit as well as the point. Finally, what you have to write there? Here I don't have place. Here I'll erase this one. So this one we can write limit of x tends to 5 mod of x minus 5 is equal to f of 5. So at the point of 5 is also, this is continuous. So the graph is continuous. I hope you understood this one. See the next question. Here I have written, the place was not sufficient, that's why I erased everything. Is the function f is defined by f of x is equal to x if the value of x is less than or equal to 1, and 5 if the value of x is greater than 1. And you have to check the continuity of this function at x is equal to 1, x is equal to 0 and x is equal to 2. Different points are given. In these points you have to check whether the function is continuous or not. First we'll start with at x is equal to 1. Right? To check the continuity of this, you have to check whether the left hand limit is equal to the right hand limit. So this is now limit of x is tending to 1 minus f of x. So the value of function limit of x tends to 1 minus the value of x is less than 1. If it is a value of x is less than 1, so the function will be x, right? So f of x is now x. So this is equal to, if I substitute x is equal to 1, this will be equal to 1. Now right hand limit of x is tending to 1 plus f of x is equal to the limit of x is tending to 1 plus, I mean the value of x is very close to 1, it is tending from the right hand side, the value of x is greater than 1. So x is greater than 1 will be, function is now 5. So this is equal to, here no value of x, so this will be equal to 5. So here we can see this left hand limit is not equal to right hand limit. Is it clear? Left hand limit is not equal to right hand limit. So we can say that the function is discontinuous at x is equal to 1. The function is discontinuous at x is equal to 1. Similarly, we check the at x is equal to 0. At x is equal to 0. So this will be now limit of left hand limit as well as right hand limit. X tends to 0 minus f of x. So the value of x should be less than 0. The value of x is less than 1. Here only less than 0 will be there, right? So if I consider the graph of function, this is 0, 1, 2, 3 and this is minus 1. The value of x is less than 1. So here less than 1, right? Here the value of x is less than 0. Less than 0 means here, somewhere here. It is very close to 0 from the left hand side. So the function will be x. I hope you are understanding this one. So function will be now limit of x tends to 0 minus. So this is now x. So if I substitute the value of x as 0, so this will be equal to 0. Now we'll check the right hand limit. Limit of x is tending to 0 plus f of x is equal to limit x is tending to 0 plus. So it is very close to 0 from the right hand side. It is very close to 0 from the right hand side. The function is here. Right, the value is here. Very close to 0 from the right hand side. So the value of the function will be same. The value of x is less than or equal to 1. Here only we will get that function, right? So the function is same. It is x. So this is equal to 0. Now if I substitute f of 0, the function f of x is equal to x. So if I substitute 0, f of 0 is equal to 0. So the function is continuous at, function is, by this we can say that function is continuous at x is equal to 0. Simple thing here, see the value of x is less than or equal to 1, the function will be continuous. Right? You consider any value x is less than 1, function is continuous. If you consider the values x is greater than 1, the function will be continuous. But at this point x is equal to 1, the function is not continuous. Because here two different values are there. X is less than 1, x will be there. X is greater than 1, 5 will be there. So at that point, at the point 1, the function is discontinuous. Remaining whatever the value you consider, the function will be continuous. Is it clear? Now we have to check with the x is equal to 2. Check this one. Obviously it will be continuous. X is equal to 2 means the value of x is greater than 1. So greater than 1 means the function will be 5. From the left hand side also it is 5, right hand side also it is 5. Right? So the function will be this is at the point of x is equal to 2, the function will be continuous, and complete this one. So the next problem, find all points of discontinuity of f and the function is defined mod x plus 3 when if the value of x is less than or equal to minus 3, and if it is a value of x is between minus 3 to 3, the function is minus 2x, and if the value of x is greater than or equal to 3, then the function will be 6x plus 2. Now we have to check where the function is discontinuous. To this simple thing is what you have to do, you have to check the discontinuity at the point of x is equal to minus 3 and x is equal to 3, because two different values are there. So we will check the discontinuity at the point of x is equal to minus 3 and the point x is equal to 3. Remaining everywhere the function will be continuous, because modulus is continuous and remaining other polynomial functions, those will be continuous. So you have to check with x is equal to minus 3 and x is equal to 3. First we will start with this one. Now I will check the left hand limit. Limit of x is tending to minus 3 from the left hand side. So the function f of x. So here you can see that limit of x is tending to minus 3 from the left hand side. So I mean the value of x is less than minus 3. The value of x is less than minus 3, function will be mod of x plus 3. Is it clear? The value of x is tending to minus 3 from the left hand side. So the value of x is less than minus 3. If the value of x is less than minus 3, function is mod x plus 3. So this is now mod x is minus 3 will be plus 3, because modulus is there. 3 plus 3 will be equal to 6. So left hand limit is equal to 6. Now we will check the right hand limit, that is limit of x is tending to 3 plus from value of f of x. So this is equal to limit of x is tending to 3 plus. So the value x is tending to 3 plus, I mean the value of x is greater than 3. The value of x is greater than, sorry, it should be minus 3, I am sorry. So this should be minus 3. The value of x is tending to minus 3 from the right hand side. So the value of x is greater than minus 3. The value of x is greater than minus 3, function is minus 2x, right? Minus 2x. Now we will substitute the value, this is minus 3. So this is now minus 2 into minus 3 will be equal to 6. So the left hand limit is equal to right hand limit. Not only this much, this is only the limits. Now you have to find at f of minus 3. At f of minus 3, what is the function? X is equal to minus 3. X is equal to minus 3 means the function will be mod x plus 3, right? Mod x plus 3. So this will be minus 3 plus 3. So minus 3 modulus is this. So plus 3 will be equal to 6. So here you can see this left hand limit is equal to the right hand limit, that is equal to the value of minus 3. So by this we can say that limit of x is tending to minus 3, f of x is equal to f of minus 3. So the function is continuous at x is equal to minus 3. I hope you understood this one. The function f of x is continuous at x is equal to minus 3. Now we will check the continuity at x is equal to plus 3. At x is equal to 3, first one, limit of x is tending to 3 minus from the left hand side, and the value of x is less than 3. The value of x function f of x. So this is equal to limit of x is tending to 3 from the left hand side. So the value of x is less than 3. The value of x is less than 3. The function is minus 2x. So this is now minus 2x. So if I substitute x as 3, so this is minus 2 into 3 will be equal to minus 6. So left hand limit is equal to minus 6. Now we will check the right hand limit. Limit of x is tending to 3 plus f of x. So the function, the value of x is tending to 3 plus from the right hand side. So the value of x is greater than 3, right? The value of x is greater than 3. Function is 6x plus 2. So function is 6x plus 2. So if I substitute this as 3, so 6 into 3 will be 18. 18 plus 2 is equal to 20. Here only we can say that the left hand limit is not equal to the right hand limit. So the function is discontinuous at x is equal to 3. Therefore the function f of x is discontinuous at x is equal to 3. But at x is equal to minus 3, the function is continuous. Important problem. See here, check the discontinuity of f, similar to the previous problem. Here I have written two problems. Both the problems are similar but the answer is different. That's why I written together. See here, the function is defined. F of x is equal to mod x by x if x is not equal to 0. 0 if x is equal to 0. Right? We'll check the discontinuity or the continuity at the point x is equal to 0. We are checking at x is equal to 0. So you have to check left hand limit as well as right hand limit. So limit of x is tending to 0 minus from the left hand side f of x. Now x may be greater than 0 or less than 0. The function is defined mod x by x. If it is x is equal to 0, the function will be equal to 0. And you know that modulus function is defined as it is x when the value of if x is greater than or equal to 0 and it is minus x if the value of x is less than 0. Right? So here we have considered the value of x is less than 0. It is tending to 0 from the left hand side. So x is less than 0. So the function is now limit of x is tending to 0 from the left hand side. So mod x, if it is less than 0, it will be minus x, right? If it is less than 0, mod x will be minus x. So I can write minus x divided by, anyway, x is as it is. So this is equal to minus 1. So left hand limit is equal to minus 1. Now we'll check the right hand limit. Limit of, I hope you are understanding this one. Already you have studied this one in the first PUC, right? So limit of x tends to 0 plus f of x. So this is equal to limit of x is tending to 0 plus, I mean the value of x is greater than 0. Whenever the value of x is greater than 0, mod x defined as x, right? Whenever the value of x is greater than 0, mod x will be x. So this is mod x is now x divided by x. So x and x will get cancelled. This is equal to 1. By this we can say that left hand limit is not equal to the right hand limit, right? If you want to check with f of 0, what is f of 0? F of 0 and x is equal to, the function will be equal to 0. So left hand limit is and right hand limit is also not equal and this is not equal to the point also. By this we can say that the function f is discontinuous. The function f is discontinuous at x is equal to 0. Important problems. The function is discontinuous at x is equal to 0. Now with the next problem, see here, f of x is equal to x by modulus of x and if the value of x is less than 0 and if it is greater than or equal to 0, the function is defined as minus 1. Here also we will check the discontinuity or continuity of a function at x is equal to 0. Is it clear? X is equal to 0. Now I will write limit of x is tending to 0 minus from the left hand side. So the function f of x is equal to limit of x is tending to 0 from the left hand side. I mean the value of x is less than 0. Whenever the value of x is less than 0, the function is x divided by modulus of x, right? X divided by modulus of x. But modulus of x, the value of x is less than 0. The value of if it is x is less than 0, modulus of x is defined as minus x. So this will be equal to minus x. So x and x will get cancelled. This is equal to minus 1. Is it clear? Left hand limit, the value of x is tending to 0 minus. Actually the function is defined by x by modulus of x. So this is equal to x is as it is. But modulus of x, the value of x is less than 0. Right? X is less than 0. If it is x is less than 0, function will be minus x for the modulus. So this is now minus x. X and x will get cancelled. So that is equal to minus 1. I hope you understood this one. Next we'll see the right hand limit. Limit of x is tending to 0 plus f of x. So the function is x is greater than 0. Right? 0 plus means the value of x is tending to very close to 0 from the right hand side. Obviously it will be positive. So if it is greater than 0, the function is minus 1. Anyway here x value is not there. So this will be equal to minus 1. So here left hand limit is equal to the right hand limit. Now we have to check at the point f of 0. What is f of 0? At the point x is equal to 0. If it is x is equal to 0, the function is defined as minus 1. So here you can see this left hand limit is equal to the right hand limit. So that is equal to f of 0. So the function is continuous at the point x is equal to 0. So I can write limit of x tends to 0, f of x is equal to f of 0. So this is the difference between these two problems. Here this is discontinuous at x is equal to 0, but this function is continuous at x is equal to 0. So this is continuous at x is equal to 0. Please remember this. Remember this also very important one. Everywhere this will be there. See here I have done two problems. Actually you can solve this problem. See here, x is greater than or equal to 1, the function is x plus 1. X is less than 1, the function is x square plus 1. So greater than or equal to 1, obviously the function is continuous. Less than 1, the function is continuous. You have to check at x is equal to 1. Is it clear? At x is equal to 1, limit of x tends to 1 minus from the left hand side, the function will be now, this is equal to limit of x's value is less than 1. Whenever the value of x is less than 1, function will be x square plus 1. So this is 1 square plus 1 will be equal to 2. So this is left hand limit is equal to 2. Right hand limit of x is tending to 1 plus f of x. So this will be equal to limit of x is tending to 1 plus the value of x is greater than 1. So it will be x plus 1. So this is also equal to 2. Left hand limit is equal to right hand limit. Now you have to check at the point f of 1. At x is equal to 1, the function is x plus 1. Right? At x is equal to 1, the function will be x plus 1. So this will be equal to 1 plus 1. So this is also equal to 2. So the function left hand limit is equal to right hand limit, that is equal to the point. So the function is continuous at x is equal to 1. So there is no discontinuity point of this one. So the function will be continuous everywhere. Is it clear? There is next one, f of x is equal to x cube minus 3 if x is less than or equal to 2, and x square plus 1 if it is x is greater than 2. So left hand limit x is tending to 2 minus, write it properly, 2 minus the value of x will be less than 2, function is x cube minus 3. Right? If it is the function is x cube minus 3, if you substitute 2 cube minus 3 will be 8 minus 3. So this is equal to 5. Yes, the value of x is tending to 2 plus. From the right hand side, the value of x is greater than 2, so it is x square plus 1. So 2 square is 4 plus 1 is equal to 5. Left hand limit is equal to right hand limit. So if I substitute x is equal to 2, at x is equal to 2, the function is again it is x cube minus 3. So this is 2 cube will be 8 minus 8 is equal to 5. So the function is continuous at x is equal to 2. So there is no point of discontinuity. Is it clear? There is no point of discontinuity for this function. So finally I can write limit of x tends to 2, f of x is equal to f of 2. In the next session we will solve some more problems based on the continuity.